All right, welcome back to video number 2 of the cell-mediated response. So when we talked about these helper T cells interacting with different cell groups to activate them, another group they interact with is the B cells, and we already saw that the other day, so we can go ahead and move on. The final group of T cell clones would be called the regulatory T cells. Now, once we have this immune response happening, we don't want it to continue to happen forever. Once the threat is gone, we want to make sure that the immune response is quelled or basically quieted down. Otherwise, your body would just be in full-on defense mode all the time, and that's expending unnecessary energy. It may end up deciding to destroy things that are good and healthy. So you have these regulatory T cells that will secrete chemicals that suppress the activity of T cells and B cells, okay? Because we don't want the immune system operating out of control, okay? That's when we have sickness. That's when we have autoimmune disorders, cancers, things like that we don't really have time to go into this year, okay? So here's a visual you will find in your book. This is comparing the humoral response to the cell-mediated response, okay? So take a look at this. Everything begins with the exposure to the antigen, to the foreign material. It all begins with that antigen being engulfed by the macrophage so that pieces of it can be presented and basically introduced to the helper T cells. Okay. And so at that point is when we activate all of this cloning, all of the, whether it be antibody production, activation of cytotoxic T cells, building the memory B cells or the memory T cells so that when these invaders come back another time, the body is ready to recognize it and fight it much more quickly than it did the first time. Okay, so those memory cells you can see here, we didn't talk about those yet with the cell-mediated response, but the helper T cells basically also are going to cause certain T cells to become memory T cells that will hang out in the body for the next invasion. Quickly, before we finish up this unit, guys, and you take your test this afternoon, I do want to talk about transplants. So when we need a transplant, whether it be skin, whether it be an organ, skin grafting, things like that, when we have third-degree burns, I think you can figure out why the body rejects something that comes from someone else, which is what basically happens in most transplants. If I'm taking a liver from someone else and putting it into another body, that person's immune system says, hey, that's not self. That doesn't belong here. Okay. So the grafts that are going to, or the transplants and grafts that are going to be most successful are called autografts. This is where you take tissue transplanted from one site on that same person's body to another. For example, when they have third-degree burn patients, a lot of times they will take skin from one part of the body and place it over the damaged, burnt tissue areas. Okay, those are successful because we have self being introduced to self, and there's no conflict there. An isograft is another thing that can be successful as well, where I take tissue from an identical twin. So basically, genetically, we are identical, so my tissue and your tissue are virtually the same. There may be a little distinction with that because people's tissues don't always necessarily stay the same during the course of their life. Genetic mutation happens just as a byproduct of life. An allograft is tissue taken from an unrelated person. Here's where we get into some of the trouble with transplants. A xenograft, tissue taken from an animal species. Now, sometimes we take pig hearts or pig heart valves and put them into humans. And so anytime that we have things taken from another person, then we're going to have to give what's called anti-rejection medication. Okay, that's not on this slide. But we're going to have to give anti-rejection medication, which is basically medication that quiets the immune system so that it will not destroy the new tissue. And that, by now leads to other disorders, with people getting sick more often, because if my immune system is being told to calm down or quiet down so that it won't reject my transplant, then it's also